Moving further from material jetting, the next one is binder jetting, where you add just a liquid bonding agent to selectively deposit powder materials. The example is the MIT process licensed to a company called Z Corp. Z Corp has now been taken over by another company. I do not recall exactly the company's name, but it has now been taken over by another company. So, or if you are making, say, a ceramic powder, ceramic component made with a binder material, you can also use this kind of a process to do that. So again, in this process, there are two separate materials. One is the powder-based material, and the other one is a binder. The binder will act as an adhesive between the powder layers, and the binder is usually in liquid form, and most of the time it is water-based, so it's very environmentally friendly process. And again, here again, you have a print head that is moving in the X and Y directions of the axis of the machine and deposits alternating layers of the material, build material and the binding material. And after each material, each layer, the object being printed is lowered down on the platform, build platform. And then the next layer comes in and builds that process. Due to the method of binding, what is to be noted is that the material characteristics are not always suitable for structural parts. And even though this is one of the fastest uh, processes of printing, additional post-processing have to be done. So you have to add additional things, like in some cases you even add some kind of an acrylate paint that will cross-link with the binder fluid to make it slightly strong, so that this can be used as a functional component. Otherwise, this process is mostly used only for um, form, fit, and function. Functional, I mean, they are not functional parts, but just to show, I mean, just for show and tell. In this case, you remove the part from the unbound powder after the whole component is built, once it is completed. And most of the time, this is referred to as 3DP technology and copyrighted under this name. Yes, now I remember, Z Corp is now owned by 3D Systems. So there has been a lot of consolidation that has taken place in this field. And so 3D Systems owns three major sets of rapid prototyping technologies. Stratasys owns um, most of the um, extrusion-based processes, etc. And then you have the metal-based, powder-based techniques also after this. So this one shows a piece of equipment. I mean, one is the actual component, actual machine, and the other one is a schematic of the build process. You can take a look at that. And so, what are the essential features of this process? You have the powder material that is spread over the build platform using a roller, and then you have the print head, which is typically like our inkjet printer head. It will drop wise deposit the binder adhesive on top of the powder. Most of the time it is a PVA based binder in water or ethanol, most of the time in water. So it's a very environmentally friendly process. And after each layer is built, the whole cylinder goes down a little bit, and then next layer of powder is spread over the previous layer, and then so on. So it builds the whole process layer by layer like this. The advantage is that you can have different colors, and you can also even use metal, polymers, and ceramic materials. Their claim to fame is that their process is generally faster than others and can be um, more made faster by increasing the number of print head holes that deposit the material. So this gives you the opportunity to allow a large number of different binder powder combinations, and so you can have different kinds of combinations here. And so this is well suited for when the internal material structure needs to be of a specific quality. The process takes longer than just depositing the material because you require the binder to be set. So you can't just build it and take out the component from inside the powder bed. You have to wait for the component to be set completely, and then you also have to have post processing to make the part stronger, so that it gives you the it cross links with the binder material for better mechanical and structural properties. But this is essentially, I mean, it's a kind of a clay type of a product. So if it falls, it is going to break into 1,000 different pieces. So, or I mean, especially if it is just starch-based powders. They claim that it can be used for making metals, polymers, ceramics, etc. And uh, so, and one thing to note is the print speed. It can print about 2 layers per minute. So it is pretty fast process. Okay. So what are the advantages? Advantages are that it can be made with a range of different colors. Um, it uses a range of materials, and the process is generally faster. And you get different binder powder combinations and different mechanical properties. But the disadvantages are that it is not always suitable for structural parts due to the use of binder material, and additional post processing has to be done so that you can get better properties. And the most important one is that because this uses a very, very fine powder, so it is a messy process. That powder can get into everything. I mean, if you are standing near that, you cannot be wearing a rubber soled shoe because you can slip and fall. So that is the biggest disadvantage with this process. So these are a couple of different videos for this process. So I would like you to take a look at that. And the next one is the material extrusion. So this is again similar. I mean, this is very much like a toothpaste technique that I was talking to you about in the last class, last set of lectures. It is dispensed through a nozzle or orifice which is heated up. So the examples of that are the Stratasys fused deposition modeling, or FDM. Then more recently you have the company called MakerBot, which has already also been taken over by Stratasys, and the process adapted by my old company, Advanced Ceramics Research, which we called it extrusion freeform fabrication. So the most common terminology is FDM. It's a common material extrusion process. It has been trademarked by Stratasys. It comes down through a nozzle where it is heated and then deposited layer by layer. Again, similar to the other processes, you build it layer by layer, then the platform goes down by a small distance, and then the next layer of material comes down and deposits on top of the previous layer. Now the requirement is that the layer that is being put on has to stick to the underlying method. Now the big advantage is that this is a commonly used technique on many inexpensive domestic and hobby 3D printers. For example, if you go into Staples, you can see a printer that is now available for $300, which is made on a technique that is based on extrusion free-forming or fused deposition modeling. There are several factors controlling the part quality. First is that it has great potential and viability when these factors are controlled very accurately. But the problem is that you can have stair-step features that can prevent the good surface finish. So you have to take it out and then rub it down with some kind of a sandpaper or something like that in order to get good properties. And then you have to further do electroless plating with nickel or something like that to give it very nice and shiny other techniques. So this is the process. One is the machine, the other one is the technique, and we have one of these machines in in my lab. So if any of you are interested, you can come by and see the machine in operation or see the machine. I cannot always claim that it is operational all the time, but it is there. You can come by and see it. So these are some of the steps of the process. And what are the materials being that can be deposited using this process? ABS, acrylonitrile butadiene styrene, or ABS, Altum, which is a nylon based, high temperature material, used to be produced by GE, but now it is produced by Solvay. PEEK, nylon polycarbonate, then or you can have binders filled with ceramic or metal powders and so on. These are some of the advantages and disadvantages. Main disadvantage is that the accuracy and speed are low when compared to the other processes. And you need to constantly apply the pressure in order for you to extrude the material out of the nozzle. Okay, so let me stop here for this set of slides, and I will continue in the next set of slides.